This is a record of the TOPS Masterclass I did at EPC a couple of weeks ago. Let's run through. So the agenda. So we're going to go through why TOPS, what we did before TOPS came along, ROPS versus TOPS, some UI basics of TOPS, work items as a fundamental unit of TOPS, attributes are important, control flow, speeding up TOPS, and case studies. I can read from a list. Well done, me. Also, HIPs will be provided to go along with this. A lot of them are already on the wiki, but I'll make the specifics that I've made for this particular presentation. There was Q&A at the end. I haven't written down the Qs or the As, but I think it was all answered. And I will record this masterclass. That's what I'm doing now, oh my word. So, what is the problem space? What is TOPS trying to solve? So, if you're watching this, odds are you've drunk the Kool-Aid and you're into proceduralism. Something that is interesting is that the proceduralism within Houdini is primarily within SOPs or the other contexts. But when you almost forget that there is a way that you could sort of take a step back from SOPs and look at the overall work that you're doing, and that isn't easily proceduralized. Usually at that level, you assume that you have a render farm and some sort of a render queue, or you've got a pipeline TD who's writing Python for you to batch stuff across many jobs, many frames, many shots. But it's surprising that that sense of proceduralism you have within Houdini doesn't exist outside of it. Well, it does now with TOPS. One of those kind of examples is, you often hear people when they're just starting out in Houdini, especially on the game dev side, and they want to make lots of fences, lots of rocks, lots of stuff, and it's easy to make within it. But then once you sort of get to the question of, okay, I've got all these different game levels on disk, or all these shots on disk, how can I run this process across all these things? Houdini before TOPS didn't really give you a way to do that, which was interesting. People would usually point at ROPS as a way of doing it, but even ROPS is a little bit too blunt for that. And I'll talk a bit more about that in a sec. And what we've all been noticing really is that there is a lot more work going on. We're all making more things in more complex ways. We had to find some sort of solution. So talking a bit more about pre-TOPS, ROPS was, again, as I mentioned, what people sort of pointed at, but it was a little bit too blunt. You have a node to represent rendering in Mantra. You have another node to represent caching a sim to disk. But in terms of what it was doing under the hood and how it did it and when it did it, you had no control there. You had some control flow options, so you could maybe make everything calculate first and hold at this point and before the rest of the chain could run. But that was kind of it. And as I mentioned before, ROPS's main sort of target was on rendering frames. Now it was designed to essentially control Mantra, and then you had a few other things kind of leak out of the side of that, but that was always the focus. It was on rendering frames. And what we do these days is, often more than frames. In some cases, for some industries, you're almost never rendering frames inside Houdini. You're doing other stuff. And the other side of that was, with this limited control flow and limited ability to control what it's actually processing, scaling up to more complex workflows got quite difficult. I'll have some examples of workflow at the end that sort of explain that more. Wedging was another side of that. So wedging I'll explain on another slide again, where it just allows you to run sort of randomized variables and run a process over and over. ROPS does have that, but it's very limited and it's a bit clunky to use. And most of this workflow that I'm sort of implying here would go to the pipeline, would go to the render queue, for example, or the pipeline TD to control. You couldn't really drive that all inside Houdini. So let's jump into UI basics. I've just checked I am actually recording. I got to this far in the previous attempts and notice I hadn't actually pressed start on OBS. So I'm just going to make a note for myself. I might even drag this over to my other screen so I can read it while I'm doing it. So first thing, where do you do TOPS? So if you've used Houdini a bit already, you would know that you can have these top level containers. So I could jump to, say Solaris over here, or from OBJ, I could put down a LOPS a LOP network here. It's the same thing for tops. So the default way to go to tops is to go to this tasks context over here. I don't like that. I prefer to, within OBJ, put down a topnet. Just so that way, whenever someone else opens your scene, this is the first thing that they see, and they go, okay, this is involving tops, and they can either go hooray or they can be panicky. So once you're in there, there is some of the basic nodes, and usually it's you're either looking for things to process to start with, or you're managing control flow, or you're getting it to do work. I'll explain that more clearly now. So in terms of finding things to do, one of the more common ways to drive tops is to use files on disk. So for example, you have a bunch of images on disk and you want to do something with each image. So the way that you would do that is you would have a folder or many folders, and you say, I want to find everything that ends in star.jpg or star. Whatever. So that's a pattern. So the node that you use for that is called a file pattern top. So I just typed file P, I found a file pattern, going to put it down. And now this node, by default, is looking for everything inside my HIP folder. So I'm going to go to my, say, HFS folder. Whoops. So I'm just going to grab everything and do $HFS. And I'm going to go into where Houdini stores its template images. So HFS Houdini pick, I believe. Yep. And so here's a bunch of images. So say I want to grab everything in this folder. So I'm just going to choose one image, for example, but then I'm going to replace the end of the path with star. And now I'm going to have Houdini execute this top node. So one of the many ways to do it is I can select it. I can go up here to this play icon with a little orange bar on it and go play, and it's done some work. And you can see that what it's done is it's found 117 things to do, or more accurately, it's found 117 files. The way that we can investigate this is a few ways. If I double clicked on one of these nodes, one of these little work item dots, this gives me information about what this work item represents. So you can see that it's found a image that is called blah, 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 pick an onstats background.png. It's got some extra metadata, so it knows it's the file extension, which is .png. It knows the file before the extension, which is an onstats background. If I want to move between these different work item dots, I can tap them, and you can see that as I move through them, you see that this thing updates. The other really useful thing to do, this hot tip, is if I use the square brackets on my keyboard, I can cycle through them. It's a really handy way to jump around these nodes. The other thing to be aware of is if you read in the docs, it'll say frequently, go to the tasks menu and click this, click that. For the longest time when I first began to use tops, I was looking around for a task menu up here in the toolbar. I couldn't see it. It is actually hiding in plain sight. So this bar here that looks like it's purely status info, and this task thing that just looks like it's a title bar is actually a menu. So that's where the tasks menu is. So this is the other way that you can generate a node. So to prove that, I'm going to have tops kind of reset what it knows about this node by right-clicking and going dirty this node, and you can see it resets. And I can execute this node again by going to tasks and generate work items. And this is a slightly different way that I'm going to talk about in a slide coming up. So there's generate versus cook. I'll explain that difference in a sec. I'm going to cook this one and the back two green icons. So file pattern is a key one. Another really common one is the attribute creates node. So you can see here that it's storing the name of the file under this attribute file name. So if I middle click, you can see that this is similar to using the middle mouse window inside regular SOPs, where I've got information about attribute names and the value. So this is the top attributes and the tops value. In SOPs, it's pretty common to take a property like, say, CD and copy it to another attribute so that you have it saved for later. Or say, you might take the position attribute P and save it as rest so that you can reuse it later on and know that it's not being modified. Similar in tops. So say, for example, I want to make another attribute that isn't called file name, but it's called my image. The way to do that is I'm going to hit tab and we're going to look for attribute, and it is a attribute create. So I'm going to enter that and wire it up. Actually, what I'm going to do is my usual cool trick that makes it look super cool. So I'm going to select that, tab, ATTRC, create, and I'm going to hold down Shift and Enter. So that will put down the node, wire it in, I'm ready to go, and give it focus. So with this attribute create node, I can make extra attributes on the work items. So in its current state, there's nothing there. So if I cook this node, so I'm going to show another way, which is the usual way that I would cook work items, which is, so one is to press this button, another one is to right click and go generate node, another way is to go tasks and generate or cook output node. And the way that I'm going to do it is with it selected, I'm going to press Shift and V, which cooks the node. So if I look here, because I haven't really defined anything, if I middle click on this work item, you can see nothing's changed. No, it's all the same stuff. If I want to make an extra attribute, so I'm going to make, say, a new string attribute, and I'm going to call it, my image. Oops. So I've just defined the name, but haven't defined the value yet. If I cook again with Shift V and have a look, you can see that I've now got my image, but it's not been defined. I could make that be a static value. So I could make that be, say, mat, and cook again. And now if I look, so if I double click on one of these things to bring up a static middle mouse window, you can see that I've got my image mat. And if I use my square brackets to jump through these nodes, you can see that they've all got the same value. But what if I want to refer to the input value? So I want to copy this file name into my image. Well, the way that we do that, which normally I think I'm going to talk about a little bit later, but I'll give it a little cheat sheet now, is you use, it looks like using vex at attributes. So you could put at file name like that, because the value we want is called file name. So I'm going to refer to at file name. Except that if I try that with Shift V, the value will be at file name. For this to work, Tops has to know that this value has to be evaluated. So that works like in HScript and most other expressions. So you wrap that in backticks. So that's now wrapped in backticks. If I cook this up last time and I look, you can see that I've now copied file name into my image. And if I jump through these different work items, you can see that it's done that for all of them. That's cool. Now, another thing which makes more sense as these get more complex, these graphs get more complex, but I'll just kind of show it now, is that oftentimes you'll be wanting to have high-level control over your network while you're manipulating SOPs. So let me show what I mean by that. So if I put down a node, which is called a rough geometry output, and make sure that this is set to not use an external SOP. I'll explain that in a sec. So if I dive inside here, you can see that this has a SOP network, and this is pre-wired. I'll explain what this all means shortly, but I'm just going to put down for now a trace SOP. And I need to make that point to this. Again, ignore all the details for a sec. Kill that one. Let's look at this one. So this will now be tracing from here. So if I paste in that, this is tracing the input image. But you can see that this is all fine, but how do I kind of preview changing this image and seeing the output down here? Well, what I could do is I could jump back up and I could go to a different thing and then jump back down. In fact, you can see that the view holds onto the last kind of context. So because I was in SOPs, it stays in SOPs, even though I'm up now in this task view, which has no real, relevance or need to change the viewport. But usually you want to be able to see both. So usually what I do is I set up my view to look like this. So I jump to my regular layout, which I call desktop mat. So this is the best way to run Houdini. So I've got a nice big parameter pane, nice big network editor. And over here is a spreadsheet. It's going to be my fat bit over there. But what I'll do is if I double click and get back to this view again, I'm going to make another pane. So I'm going to click the plus, new pane type, network view, and have this be another network editor. And I'm going to take advantage of these, either this push pin here and or this numbered view here. So you can see that in my desktop, by default, I've got these things all set to 1. So by default, it would look like that. It'd be a push pin. So if I go to no link, it would normally look like that. But what happens is if you right click on where that little thumbtack is, you get this choice of numbers 1 to 9. So I'm going to make this one be 1, and this one be 1, and this one be 1. What that means is, as I change any one of these views, if I change where I'm focused, so I've double clicked to here, these all stay locked together. So this is showing me the parameters for this particular selected node. This is showing me the output of this node in this view. But when I jump up, they all jump up with me. If I were to go over to a car network, and I jump in there, everything is now tracking with me in that view. What I've got down here is this is another network view where this has been pinned, or I can right click on it and make it be 2. So now this is in its own little world. The reason this is useful is I can have this one be viewing my top graph, while this one and all these other windows are viewing where I want to be doing work. So this way, if I head again, I can be up here and I can be changing inputs up here. If I press P on my keyboard, I can bring up a little mini foldable parameter pane. So I can be changing properties and stuff of my top graph while I'm also editing stops. This is the best way to use stops, I find, in my opinion, but my opinion is always right. To talk a bit more about the clicking, resetting, and selecting of work items, which I did just cover before, but I'll do it again. So so on any given node, you can press Shift-V to cook it. Green items are cooked work items. So each one of these represents a thing. So if you're coming from ROPS, you would normally think of that as being a frame, but you can see here that this actually represents images which are found on disk that I can do work with. They could also be frames of a simulation, or they could be individual OBJs on disk, or they could be just text attributes pointing to, URLs. They could be whatever you want them to be. That sort of polymorphism that a work item can represent whatever you want it to represent is quite powerful. So you can see that, when I've got nothing selected, they are a bright green. If I select one, the selected one turns yellow and all the rest get dimmed down. And that means that this active state of this node is kind of available for use elsewhere, which I'll explain a little bit more in a sec. If I want to reset the cook, I can right click and I can go dirty this node, and it basically forgets what it's done. So there's a strong analogy here to simulation, where you have a cache and you can invalidate the cache, you can reset it, you can see which frames are cooked and which frames haven't been cooked. Similar here, similar ideas. Anything else to cover on that? Probably not before we get into some more specific stuff. So that's all those things. Whoops. Here we are. I'm jumping back. I'm jumping forward. We were here. Good. Okay. Sorry. I'll edit all this out. Next, ROPS versus TOPS. So again, really getting into the specifics of this. So I'm going to, you can pause on this for a sec, but I'm going to move it to my other screen and talk through all these points. So the way that I kind of, the mental model, which if you've watched my Apex talk, I like to think about mental models. The ROPS versus TOPS is, to me, OBJ versus SOPS. So with that, I'm going to jump out to OBJ and do some analogies. So say I've got a box, I've got a camera, and I'm going to move that camera by putting it over there, and I'm going to have a sphere, and I'm going to put the sphere over there. So at this top level, ignoring the top net for a sec, you can see that this is high-level summaries of what's going on. In terms of the actual specifics of what's going on with these things, and if you know SOPs, you know where this is headed. I can't see it from up here. So even if I go to the GS spreadsheet, oh, it does. There you go. Interesting. Yeah. Okay. Ignore the thing about the GS spreadsheet, but you can't really sort of get to what's going on with this box. For that to happen, I've got to dive into the box SOP, and now I've got access to all its points, and I can put down more things. I could do a randomize on the color SOP. There we are. Randomize that. So you can do work here, but then when I jump back up, that's all sort of encapsulated and wrapped up for me. I can't really sort of manipulate it at that fine level. Similarly, if I put down a ROPNet and dive inside, there are nodes in here that some of them do things that are kind of sort of similar to what ROPS does, to what TOPS does, but it doesn't give you a lot of control. So if I were to say put down a mantra ROP, remember mantra? Yeah. This gives me sort of a very high level summary of things that this can do, but when it actually starts, I don't really get a lot of control or a lot of oversight of how far through it is, what's left to go, are there any dependencies that each frame needs from a previous ROP node. It's very high level. Versus if I go over to TOPS and I put down, there is a mantra ROP in here still. Yeah, ROP mantra render. So you can see this has very similar controls, but if I put down a frame range and I go generate node, sure, this actually makes an individual work item dot to represent every frame. That's quite handy. So that as this cooks, you'll see these things now go from gray to work in progress, which I don't remember what color that is, but then it goes green when it's complete. So it has much more knowledge about what's going on with the render. That's quite useful. And some of the tricks TOPS lets you do is you can get quite so complicated dependencies down to the work item level. So if I were to cook this thing again, so if I right click and go generate node, sure. You see that if I click a node down here, this thing, TOPS is showing you that it's tracking dependencies, that this work item for the ROP geometry is relying on this attribute create that is relying on this file pattern top. So it's very atomic dependency tracking. This is also quite useful in that it can be very aware that even right down to images on disk. So if I were to run this and I'm making a BGO per work item, if I delete 2 of them, if I recook it, it is aware that all the rest already have output on disk. It doesn't have to recook them. It'll only recook the 2 missing things. That level of control is something you could never get out of ROPS, and that is one of the many things that makes TOPS quite powerful. Let's bring this up here again. Yes, it was all covered. Okay, so work items. Pause this for a sec. You can copy it down, get a screenshot. I'm going to move it back over to my second screen. So what are work items? So it's the equivalent of a point in SOPs. So it's the smallest indivisible unit of work. As I mentioned before, if you're thinking in terms of rendering, you normally think of that as being a frame, but they can be anything. They could be, as I've got here, a path to something on disk, or they could be a call to an asset in Shotgun. They could be a call to a particular sim you've run. Whatever you want it to be, a work item can be that thing. One of the really useful things that you can use TOPS for is wedging. So I'll finally get to explain wedging. So if I tab in a wedge, so what is a wedge? A wedge lets you define a range of values. So you can see that by default, there is nothing here. And if I cook it, I get a single work item that is just doing nothing essentially because I've got nothing set up. But if I go to the wedge attributes, I can click it and I can make up an attribute name. So I'll call it this, say, gravity, for example. And once that's entered, I get to control what kind of attribute that is. So this is a float. And I get to control how many values it's going to make and what is the range of those values. So if I say the wedge type is a range, and the values are going to go between, say, negative 9.8 and negative 15, and I'm going to make 5 variants. If I cook this node again with Shift V, you can see I've now got 5 work item dots. And if I double click it, you can see that this first one has gravity at negative 9.8. The next one is, whoops, make sure my focus is over here when I press my square brackets. Click. Choose one, there we are. Negative 9.8, negative 11, negative 12, 13, 15. So you can see that this is doing a nice clean interpolation between the start and end of my range. Or I can go random samples. And if I click this again and look at these values, you can see that these are now randomized values between negative 9.8 and negative 15. You can hopefully see that that is useful. And I will show reasons or how to use that coming up shortly. Next slide, TOPS attributes. Again, pause for screenshotting. So maybe I'll read through some of this. So as I've kind of shown you already, TOPS attributes are like point attributes. So the information that belongs to work items. There are some common ones. So you've already seen with the file pattern top, we have the file number, the file name, the file extension, the full file path. If you're doing a simulation or some output rendering, it'll have the frame number. Or you can put in whatever else you want. So you've seen wedges. You could have, if you are rendering for a short film, you could have the shot and sequence number. You could have a poly count target if you're processing assets for games, whatever it needs to be. Now, similar to SOPs, where there are some built-in attributes that are always there. So ptnum and cd and p. TOPS also has some built-in ones that always have pdg underscore as a prefix. So the important ones are pdg underscore item, pdg underscore input, pdg underscore output. They're the primary ones. The rest of others are fairly common. So in the way that, say, cd isn't required, but it's often there. At file name is often there when you put down a file pattern top. A gotcha, which I'll warn you now, is that when you start to get some more complicated TOPS workflows, and you start to rely on pdg item, which is very similar to using ptnum. ptnum in points automatically sorts itself down, so that if you go from, say, points, you have a line that has 50 points on it, and you delete the first 25 points, the resultant ptnums won't be 26 to 50. It all gets shuffled down and reset to be 1 to 25, and they're all unique. Whereas the difference is with pdg item is you can have pdg item numbers can often be dangled left where they are. If you are merging streams, you can have duplicate numbers. PDG and TOPS by design does not try and ensure collapse consistency with the things. There are ways to fix it, but you have to remember to do it yourself. Something I didn't talk about is PDG and where that comes from. So that's analogous to in LOPS and Solaris are the same thing. TOPS and PDG are the same thing. So PDG stands for procedural dependency graph. TOPS is the short name. I really only ever call it TOPS. So let's look at some examples of this. So if I go grab this one, put it over there. So if I were to have another wedge, so I'm going to duplicate this guy. Let's equal B. So if I look at this one, and you can see that this has an index of 0 for this first work item dot. And if I go through the others, it's 0, 1, 2, 3, 4. If I click this one, this also has index 0, 1, 2, 3, 4. It makes sense because they're separate streams. If I merge these like this and look at this result, you can see that this one has an index of 0, and so does that one. 1, 1, 2, 2, 3, 3, 4, 4. It doesn't really affect TOPS itself. TOPS is fine. It's more about you. If you say, well, I just want to grab the first work item and do work with it. So you would say, well, I'm going to filter by PDG index of 0. You'll be caught out because you're actually going to get 2 items. The quick way to fix it is to put down a sort top. So put down a sort, and there's a checkbox, ensure unique work item indices. And if I click this one and have a look, you can see that this now has index of 0, 1, 2, 3, 4, 5. This display graph, I think, is implying that it has to know all of the work items before it to know how it can sort out the numbers. So again, it's keeping track of the dependencies of things. It's all very useful. Right, so that's that. Special mention has to be called out for PDG input and PDG output. And that's best just explained in context. So if I jump back over to what we had before with the file pattern. So if I click this and look at one of these nodes, so you can see that this very first node, because this is by definition essentially a primary input node. It can have other inputs, but usually this is the first node in the chain. So if you look at the attributes on this particular work item, you can see that there is an output, which is the file path for this particular image. So it's the full file path, but there's no input because this is the first node doing all the work. If I jump to the next node, you can see this one now has an input and an output. And you can see that in this case, they're the same thing because the input is the image and the output, this node hopefully wouldn't change that. So it's going to pass on the output as the same path, the same attribute essentially. Now where that changes is you can imagine that TOPS lets you do a lot of transformation of things. So say for example these were zip files on disk, and I use top node which can unpack zip files. Well, the output there isn't going to be the zip file. It's going to be what are the contents of the zip file. So it might be a path to a folder instead. Another analogy is you might have a bunch of OBJs on disk, and then you're rendering them. Well, the output of that final render node isn't the OBJ, it's the image. So these things change by design. They have to change. So these are sort of implicit things to tell you, what is the input I'm working with and what is the output. But if you need to keep track of that input, then that's what you use an attribute crate for. So that's exactly why I use attribute crates a lot for, is that rather than say file name, I might grab the PDG input like that, because I need to be able to track that through time. And in fact, I can show that. So this node here, this is a ROP geometry. So this is expecting to write 3D models to disk. If I just generate this node, if I click on one of these nodes, you can see that the input is the image as expected. The output is, it expects that it's going to write it to a bgia.sc. So if I were planning to use, say, downstream further on, a reference to the image, well, that image reference is lost, apart from the fact that I actually saved it myself. So I saved it to my image, the image path by sort of stashing the PDG input value to a separate attribute. So really important to not rely too much on PDG input and PDG output. They're there, they're very useful, but know that they're transient. And if you need a permanent record, copy them to another attribute. Back to my list. Control flow. Yes, so as I mentioned before, TOPS tracks right down to the work item. So whereas ROPS is just rawly tracking dependencies between the nodes, TOPS tracks right down to the individual work items. Now the big advantage of this is that because it knows exactly what are the inputs required for any given individual frame or any individual simulation right out to disk, it can track all the way back and see what are the other work items that it relies on, and it can be cooking individual work items rather than cooking the overall node as, say, ROPS does. What that means is that it can fire multiple threads on your machine or on the farm and just keep your machine as maximally busy as it can. That sort of like super fine-grained dependency tracking can get a little bit overwhelming at first, but it's very, very powerful. Another big side of this, which is very interesting, is that whereas if you try to make sort of complicated control flows with ROPs, you can never really be sure they were going to work until you actually tried it and cooked it. Whereas with TOPS, because it shows you pretty good understanding of how things are connected, you can design flows without actually doing any cooking. And I'll show you what I mean by that. I'll put that aside. So you can see here that, as I choose nodes, this is showing me the dependency tracking between these different work item dots. Another side of it that I'm going to talk about a bit more is this idea of cooking versus generating. So you might be wondering why these two are green and this one is gray. So a big part of TOPS's design is that it should be able to, wherever it can, understand what a node is going to do before it actually does it. So by that I mean, if I just cook, say, this node again from scratch, can I even generate this node? No, that's what I thought. So if I dirty this node and I go generate node, I can do it. Interesting. So wherever it can, TOPS tries to have the option of saying, what is the most minimal amount of work I can do so that I know how many work items I'm going to make, but not actually do the work. So in this case, for example, this file pattern top, it can take a peek at the contents of the directory and know that's going to be a fast operation. So it can pre-populate out these nodes. I'm curious if this will show me, yeah, it has enough information that it can fill it out. Let's try the same trick on this one. So I can right-click this and go generate node. And you can see that because it knows that there is a one-to-one relationship between all of these work items and all of these work items, it also knows that it's going to make 117 things to do, but it's not actually cooked it yet. We can do the same here. So even though this node is actually under the hood, would be loading up each image, running it through a trace crop, and then it would write out that as a BG on disk. I can right-click and go generate node. And again, it knows what it's going to do, but it doesn't actually do any work. This is really important. A lot of the work that you do in TOPS tends to be controlling, very long, very slow processes. So imagine that this ROP geometry node, rather than each node just being a trace cop, it's running a 2 million point scatter cloud and a big simulation and a big decimation. It's doing a lot of work. If I were trying to design this workflow and I had to wait for it to bake every single time it did it, I'd get nothing done. But being able to rely on this generate mode, so it just previews the work that's going to be done, but not actually do it, it's really, really powerful. If you want to actually cook it, then that is the difference between a generate and a cook. So cook actually does the work. So with these kind of nodes, cook and generate are almost synonymous, which makes sense. So I'm going to cook this one, but then this guy, you can see that this generate is instant, but if I were to generate it, so say cook, sorry, that's not what I wanted. I wanted to cook the node. This warning comes up a lot. And the reason is that, let's just start and do it. So I'm going to hit save and continue. So what this is doing is, under the hood, this is actually firing up Houdini in a command line mode. And once it's ready to go, it then gives a copy of the HIP to that particular Houdini command line instance, does the work, saves the file, gets shut down. Then it fires up another one, and it does the work and shuts itself down. So because each of these things lives in a totally separate context, because the idea is that you want to be able to keep working here in your GUI while there are other Houdinis behind the scenes doing the work. This is allowing me, get my thoughts together. So because this cook process is quite slow, it's useful that TOPS gives you the option to say, when I want to actually do the slow work, take as long as you need. But if I'm designing the workflow, if I'm designing how these nodes are going to interact, I want to be able to do that quite quickly. So that's why we have this generate versus cook separation, which is quite useful. I'm going to stop that by hitting escape. Yes. As an aside, so I mentioned before that each time that I go to cook, it'll ask me, do you want to save? I'm going to dirty this node and then cook it again. So I was temporarily flummoxed there by the fact that I went to dirty this node when it only had about 8 cooked, and then I pressed cook again and suddenly they're all cooked. It's like, I'm quite sure they're not. This is another great example of Tops is smarter than you. Well, Tops is definitely smarter than me. What's happened is that I have, like an idiot, set the output for this, because I didn't change it from its defaults, to always write to the same file location. So you can see that this is using $OS for the node name and $F for the frame. Because I'm not changing the frame, it meant that those 4 frames that were completed all just went to the same file. So EPC masterclass.1.bg or .sc. When I asked this node to recook itself, it tried to be the laziest it could be. That's a big feature of Tops. It's trying to be as lazy as it can. And it said, well, where do I expect the output for this particular work item to be? Well, it's going to be to this path on disk, but that file exists. Oh, the work is done. So I'm going to mark myself as being complete. That is a feature, not a bug. So if I were to change this so that rather than being based upon $F, I will change it to be PDG index, because that's really what has to sort of change per node. Now, hopefully, when I try to cook it again, it'll recognize one file as being complete, which will be frame 1, and the rest will say, I am uncooked, and you can see there. So the first one, because it starts from 0, so the first one was marked as being complete, but the 0th one identified that it wasn't cooked and it's now cooking, and number 2 was recognized that it's not cooked and it's cooking. What I was going to say was, so if I tap escape, stop cook, and go, yep. Every time that I cook, because of that requirement for it to have to save the HIP, it'll ask you every time. I find that slightly annoying. So usually, when that dialog pops up, so I'm going to just change this slightly just so it knows that there's a difference here. I'm going to put an M in there, because why not? So if I do it again, this is saying the HIP has changed. I've got to send this HIP out to all these other Houdini instances. Do you want me to save? And you go, yes, of course you do. That's why whenever this comes up, I click on this icon to say, don't ask me again, and save and continue, which means that it'll always save by itself before it sends it off to the other instances. Maybe it's dangerous. I like to live dangerously. I'm also impatient. As much as Tops is lazy, I'm also lazy. Go back to the notes. Yes, that was all about control flow. So I'm going to move this over to here and go to speeding up Tops. Okay, so as you've just seen, when you ask Tops to actually cook and do work, it's going to start hyphen. So hyphen is basically Houdini Python. So it's starting, which is Houdini without the GUI. So it starts it up, gives it the HIP. It says calculate this work item. It does the work. It gets shut down. Starts the next one. Now, a big potential issue here is that if you are running any sort of non-trivial Houdini session, so you're in a work context, you're in a studio, your Houdini probably takes a little while to open, 10 seconds, 30 seconds, maybe a minute if you're particularly unlucky. If your GUI takes that long, so does your hyphen sessions. So really, you're paying quite a big cost that for every work item there. So you can see that in this particular session, the actual cook time for this, because all it's doing is loading an image with a trace cop and running it to disk. So I'm waiting 30 seconds for it to do maybe a second worth of work. That's quite wasteful. Wouldn't it be good if we could have a way to speed this up? There are a few different ways. One of the most useful is called services. So I'm just going to stop this for a sec by hitting escape. So from what I just described, that it is calling out to Python, starting up Houdini in its Python non-GUI mode, gets a hit, does the work, shuts it down. Starts another one, gives it the hit, does the work, shuts it down. You're probably saying, why does it shut it down? Why can't it just stay active and just keep giving it updated hips, or just change the reference to the work item every time? That's what services are. So if you go to your hidden task menu and go down to the bottom, you've got this thing, PDG services. So if I choose this, we get this GUI, and we've got, you should have a bunch of pre-configured configs. So the one we're going to use is this rock fetch one. So in its default state, what this is going to do is it's going to make a pool of 5 Python workers just sitting there ready to go. So I'm going to hit start. And so the first time you start it, it's going to take about 30 seconds because that's how long my Houdini takes to start. But once they're all set up and ready to go, this icon will go green. So I might just pause for a sec. Oh no, there it is. Got it. So now we've got 5 workers ready to go. So now, if I jump back to my my session, you have to opt in. So you have to tell Tops, yes, use services if they are available. So if I go across to schedulers, I believe, no, it's under rock fetch. So you go cook type, and you go to service. So now, let's watch how fast this runs. So I'm going to hit Shift B, and you'll notice that all the ones that it knows are green, they will stay green because it'll recognize I've got a file on disk, I don't have to recook it. But let's see how fast it cooks the rest of these. Whee, that's what we want. So it errored on 1, and I'm guessing that is because that is not an image. So if I click on that, yep, it's an SVG. So that makes sense. So that brings up a nice little example of, how do we filter for that? So one way we could fix that is I could put a filter on that extension type. So there are built-in ways to do it, but there are some great labs tools to help you just get to where you need to be faster. So if I do a filter by, there's a labs filter by value. I love this node. So if I put that down, now I'm going to say, if the operation is, let's say, so the value is going to be extension, because that's the name of the attribute. Extension, is that how you spell extension? EXT, yes it is. Cool. And the operation is if it contains SVG. So let's see what happens when I run this. So this hopefully filters to only that one. So I'm going to flip this operation to say invert the result. So now this is going to be everything apart from that SVG. So you can see that whereas before I had 117 work items, now I've got 116. So now when I cook this, it will have no errors. But also, fingers crossed, it will also do no work because it should recognize that it has things on disk already. And it did exactly that. So that's pretty handy. Yes. So let's go back to here. So that's services. Services is the way that I use Tops the most. The other way is called in process. So other bits of sort of handy control flow or just sort of ways to control Tops is if I right click on this node and I can go look at where these things were put on disk. So I can right click on this one and I can go view work item output, and it should make me a Finder window. Yep. And I spend to use it on Linux. My Windows, my Macbox here is being a jerk. Oh no, it's firing up the actual geometry viewer. That's handy and silly. Let's see if that fires up. There it is. So yeah, so that is the thing. That's cool. Usually what I'll do is I will browse the output on disk. So I'm going to go look at where this was writing out the images. I think you can right click here normally. Where is that thing? Can't find it. Doesn't matter. So I know that it's going to HIP. So I'm going to just grab this whole path here, go to my trusty terminal, and I'm going to clear the output, make this a bit bigger. I'm going to CD to that location. CD and the command you full. Yep, and I'm going to open that location, and you can see here are all my files on disk. That's cool. Just going to go back to a regular list. So just to kind of, again, prove the point, I can delete some of these files. So I'm going to just command like that, maybe that one. I'm going to move to trash. And if I run this again, it will immediately identify the missing ones and recap them, which is quite handy. If you want to just delete the whole thing in one hit, you can right click and go, where is it? Delete this node's outputs from disk, which brings up a dialog. So this shows all the outputs, and you can choose some or all. I'm just going to select all and go accept, and that will delete all the images from disk for you. So if I look here, you can see it's now deleted all the images. These are the old ones from the old format. So I'm going to right click and delete those too. So you can see it's very perceptive. It's very aware of the files that each node makes, and it can be very atomic about what it deletes. So that was all background information. What are some other ways of calculating these results quickly? Well, another way is rather than have this run out to a separate Houdini Python that is running in the background with services, is I can say, you know what, just use my GUI. I don't mind my GUI locking up, just get it done as fast as you can. So for that, you change the cook type from service to in process. So in process meaning this process, my current GUI session. So if I cook this now, this will cook one at a time. They all error for some reason. But you can see my Houdini is kind of locked up, but it's doing the work. Now, I'm going to make this a warts and all thing. Let's go see why this is erroring. So I look at this and I double click. It's because I have got a bad path here. So that's because this looks like this PDG HFS alias is failing. So let's see if we can fix that. That's going to be probably back here on the attribute create. So it didn't like this thing. Why was it changing that? Is that because... So PDG and TOPS likes to use various aliases for file paths, largely because it has to be able to be farm compatible, and it has to be able to run across different OSs. So that's gobbledygook, this PDG HFS, is referring to where the Houdini install is. So it's going to recognize that I was using a path referring to Houdini, but it doesn't seem to recognize it later on. Why is that? Let me have a think. Okay, so time has passed. A couple of days, in fact. Had to contact side effects support, but they were great. They gave me a good answer. Thank you, Tyler. Thank you, support. It was as I suspected. So it was that _HFS alias that's used by TOPS. And it seems that the in-process scheduler in this particular build of Houdini, it doesn't understand it. So you have to help it expand it properly to the full file path. This is fixed in Houdini 21. Sounds like it's going to get backported anyway, so by the time you see this, you may not even need to do this workaround. But the answer is this. So back in the attribute create, I was using this at PDG_input. As that trickles through, again, the system will recognize that it has to alias the top part of the main Houdini file system so that if you're running on Windows, it knows where to find it. If you're running on Mac, it knows where to find it. We want to get rid of that. And so here we replace PDG input with this form instead. So this is the more, I guess, like strict version or the more complete version of using PDG input that's driven from HScript. And so this is essentially doing the same thing, but this 0 or 1 at the end means do you allow it to be substituted, or do you hard code it to say be the full path, don't be fancy. So if I make it 1, it says be the full path, don't be fancy. And now when I cook, you see that this is what I wanted. It's doing it in process. It's very fast. So that one answered. I'm going to go back to my notes. 3. So, and the last one is the farm. So I definitely don't have the context to talk about that here. But you can imagine that a lot of this organizational stuff, so not talk about, I can't demonstrate it. But a lot of the stuff we're doing here, clearly would be advantageous to run across multiple machines if you had them. Within TOPS itself, you have different kinds of scheduler. And so if I just go to the schedulers folder, you can see that there's the ones that we spoke about. So you can be very specific in terms of you can have nodes represent the different kinds of processes, and you can link different nodes to different processes. But usually what you do is have one master one, as we do here, this local scheduler. And you can have built in either one for deadline or one for HQ. Both have pros and cons. So deadline, it's probably used more widely by most studios and places. The problem with deadline is that it's not quite abandonware from Amazon, but it's not far off. So if you do run into issues, you're generally relying on the community to give you support. HQ, it's a reputation for being a bit difficult to install. I think it's getting better. The main advantage there is that it is made by side effects. And so if you do run into issues, and I can hand on heart say we've had a few issues over the years, side effects have been very good about trying to help out. So we've had lots of very specific bug fixes for HQ, for tops, the combination in between. I know it is an active project for side effects to make it better, to improve it over the next couple of years. So keep it up to me. I would recommend using HQ with tops. It's the nice middle ground that it is free-ish in terms of you get a license of HQ when you buy Houdini, but it is supported by side effects, which is quite good. The upshot is ultimately when you change your scheduler, so you would point this to your particular farm machine ID, and then on the top of the top net, you say which is the scheduler to use. And so in this case, I might swap it to the HQ scheduler. And now if I had that configured, it would use the farm instead. And what you'd see is almost every single dot goes out to a separate work machine. So it maximizes your farm resources pretty effectively. So using the farm is pretty good. Next slide. Case studies. Okay. So, if there's one thing that I think the world needs, it's more rock generators. So let's have a look at some of these. Am I in the right folder? I am. That should be Houdini. And let me just pause for a sec while I find them. Okay. So here is a rock generator. So the usual thing, I think everyone has tried this at some point. So we have some sort of shape. So I have a choice of shapes here, a platonic solid or a sphere. I size it so it sits on the ground plane. I have a plane that scatters a few points, and I copy the spheres onto those points. So that's 3 spheres. And then I have a bunch of noises just to sort of give it some very broad noise, some finer noise, a slight peak. That's usually 0.001, negative 0.001. It's a tiny bit of a sharpen backwards. Recalculate the normals, add some color noise, and then use that to drive HSV noise, and then we have a rock. So you might knock this up and then show it to your supervisor, and they go, great, make me 100 variations of this, please. And so normally you'd go, okay, I suppose I can keyframe it on the timeline and try and do it. But now you should think, hey, what a great opportunity for tops. So that's what we're going to do here. So if I jump up to the top of this network, you can see I've got my rock stop context and a light and a material net. So right from the top here, I'm going to make a new top net. And so this is where we're going to use wedging, and we're going to use a geometry output. So I might, to start with, make a wedge top. And so first thing, we want to go back to the setup. So in fact, what I'm going to do, I'll make this one be my top overview like that. And then this one over here will be where I'm going into SOPs. So I'm going to look at the setup and go, okay, what are the things that I want to randomize? So one thing might be just the number of points. So I might want these little collections of rocks to be, say, as few as 2, but as many as, say, 5 or 6. So let's start with that. So I'm going to go to my wedge top. I'm going to move my big fat head over here. And I'm going to make this first wedge value. Get my wedge thing so I can see it. Stupid spinny mouse. Come on, focus. There we are. So I'm going to make this first wedge attribute be the number of rocks. So we'll call this, rock count. So rock count. And I want the range to be between, say, as few as 2 rocks, but as many as 6 rocks. So if I, and then how many randomizations of these rocks do I want? So let's say I want 10. So if I immediately cook this node with Shift V, and if I middle click, you can see that the rock count here is 2. And the next one is 2.8, 4.6. So straight away we have an issue because these should be whole numbers. And so that is set here, the attribute type. So I'm going to change the attribute type from float to integer. I'm going to recook it. And now we get, this one is, actually recook it. There we are. And the rock count there is 0 for the first one. Because it's reset the numbers. Silly me. 2 and 6. Cook again. Okay, so now we've got 2, 3, 5, and 6. So this is going up linearly. I want that to be randomized. So I'm going to turn on this random samples button, like that. Recook. And now if we have a look, we've now got 4, 3, 2, and 3. So it's being randomized. That's what we want. So the next question is, how do we use that over here? Hopefully you've already jumped ahead, but it's going to go to basically this scatter node here. And rather than it being hard-coded, I'm going to use this rock count attribute. So I'm going to copy that. There's Command C. Going to go over here and do @rock count. So I can click and I can see that's now 4. And if I step through these wedge attributes, you can see that that's now being driven through tops. That's pretty cool. A few little minor gotchas. Hey, Matt, you might say, how come you didn't need backticks? Backticks are for strings, is the bottom line. Because this is a parameter that only takes numbers, you don't need the backticks. If I were to be using another wedge attributes on something that actually requires strings, like say this wrangle, for example, or like on a group field or something, then you have to wrap that in backticks. So that's hopefully the only mental rule you need to remember for expressions and tops. So that's one thing there. What's another thing we would like to randomize? Maybe the noise parameters inside this point VOP. So if I jump down to here, so you can see that if I double click and look at the point VOP, I've got this very simple network where I'm taking P, running it through some Worley noise and a displacement, and out again. And it already exposed some of these parameters to the top of it, just so it's easier to drive. So these are these things up here. So I've got this offset parameter which slides through the noise. That feels like another thing that we should maybe randomize through tops. So I might so I'm going to make another wedge attribute. I'm going to call this one noise offset. This can be a float number, and let's go, I don't know, roughly number between say 0 and 10 feels good. That's a nice wide range. So 0 and 10, we will leave that as a float. We will make it be random samples, and we'll recook it. So now if we look, we see we've got rock count and now noise offset. And now we can plug that directly into here. So I'm going to be at noise offset. And so now as I step through these different options, you see we get different noise offset amounts. If I left mouse button tap on the offset name, it'll toggle between showing the expression or the value of the expression. So I can step through and see those things there. So that's cool. What other things might we want to control? Let's go down to the bottom, maybe the color. So the color is being set by this set HSV node. So this is just using some simple showy vex to set up some sliders and then to use these to drive an HSV to RGB node. So if this is the hue, maybe we don't want to change the hue too much because that's going a bit too green and lurid. But we can maybe change the saturation, might be a good one to change. And so again, you just want to get a sense of the range of values. So maybe down as low as 0.2, maybe as high as 0.7. Feels good. Let's try that. So let's make another wedge attribute. I'm going to call this saturation. And the range, again, is a float. Random samples between 0.2 and 0.7. We will recook. Now we can see it there, saturation. And we'll throw that right into here at saturation. like that. And so now I can see as I step through these values, we get different amounts of rocks, different offsets of the noise, and different colors. I'm looking at this and thinking that I can perceive that the finer details aren't moving enough. Let's go randomize that. So that's coming from this second attribute noise, this one here. So I might want to change this this amplitude a touch, or I might want to change this noise pattern and maybe this offset here. Maybe, yeah, why not that one? So this offset here. So we'll call this detail offset. Sounds good. So let's go to make yet another attribute here. I'm going to call this detail offset. And we'll make this be, again, just between 0 and 10. Random samples. Cook it. And we've got to plug this value into here with an at in front of it. So now if we jump down to the bottom of the output, we can step through these nodes and every rock should be a delicate, unique snowflake. Yes, it's fabulous. Cool. And so the next thing is, how do we output it? So back when I started using tops, I would have probably put a rock down here. Whoops, not that one. A rock geometry output, this one. And then driven it with a fetch. Let me show you how to do that just for argument's sake. So immediately after this wedge, you put a fetch top. And simply we're going to tell this fetch top which other node does it have to reach through kind of Houdini to push the button to say render now. And so obviously it's this guy here. So what we're going to do is so this is the other advantage of having these two network panes, is I can directly drag this into here. And that's now set the path for it. Now, like before, I have to cast my mind back to when I recorded the previous section of this. Hopefully that one had the same issue where if you leave it in its default state, it's going to write all the files to the same file location, because by default, this is just referring to the current frame. There's nothing to say what is the unique index per file. So if we jump up to this wedge, we have an index which is unique to every work item dot. So that's what we use. So we can replace the $F with a PDG index. So that has to come backticks because it's a string and it's PDG underscore index. And so we can verify that by clicking on the output. So middle clicking in this case because it's a string, to jump to the end of the string because that's annoying. So if I just generate this node in static mode but don't cook it, I should be able to step through these values and see that these are getting unique names. Let me just widen this across so you can have a look. So if I step through these names, you can see that this is doing it as I want, where the file name is being unique per thing. So this works. In fact, let's just live. Let's just do it and cook it. So you can see it's cooking. This is spinning up Hyphen in the background because I haven't set up services yet, so it's a bit slow, but it's doing what I asked it to do. This is cool. The problem, though, with this is if you get too much into this sort of rock fetch workflow, it can be hard to follow for others because you are looking at this top flow and you're jumping out to another context, and you're jumping back here, then you're jumping out to another context. I have learned to stop using this. Instead, what I would do is I would not use a fetch and not use the rock output, and I would put a rock geometry output here. And I would, in this case, just copy this entire setup. So I'm going to hit Command C. I'm on a Mac. Go to this rock geometry. I'm going to call it Make Rocks. Like that. And in this case, I want to put those nodes inside this context. So I'm going to say, don't use an external SOP, use the internals. Dive inside here. And I don't need the incoming PDG input because we're making geometry from scratch. So I'm just going to go and paste this directly in here, paste the output to there, and we should be good to go. Just for argument's sake, to make it a bit faster, I'm going to convert this to an in-process. See if I can remember how to do it. I need to change the scheduler to a, let me pause again. I found it immediately after I hit pause. So on the rock geometry output node, go to rock fetch, change the cook type to in process, and let it cook. And this should be much faster. And there we are. So now if we look on disk, we can right click and go to view work item output, and this should fire up gplay. I can view it directly, or I can go to where the output actually is. Didn't fix up this file name, silly Matt. Let's fix that before I forget. So there we are. There's my file over here, like that. But I don't want that. I want to make sure that this is written to the correct location. So I'm going to change this path to backtick pdg underscore index. Write that out again. And I should be able to go to the folder where I have saved these things. Oops, got that wrong again. Oh, no, that's right. They would have done it in context. So I'm going to go to where my files are, which is not there. Documents, keynote, because it was a presentation, tops, geo, and this was in media hips, one up, geo, and there's my rocks. So originally I made OBJs for the purposes of the demo. These were BGOs, so I can't preview them, but that's okay. I'll just change this to be, rather than writing at BGOs, I'll make it right at OBJs. Write it again. And if I go back to here now, I can see there's an OBJ now for every matching thing. And I can use the spacebar preview on Mac to have a look. And there's my rock. And I can step through these files. Pretty cool. So that's the basis of a rock generator. The other thing that's is probably worth discussing is how these things in this particular context can be used to make even more variations. So at the moment, this wedge node, so I've got a single wedge top, and I'm making 10 variations, and each one gets a certain, like, completely randomized rock count, noise offset, and saturation and detail offset. I hope I covered it in the previous one, but let's assume that I didn't. What you can do is you can chain multiple wedges together, and you get combinations of these things. So you get sort of it's like sort of it's x to the n combinations of things. So it's easier just to show like this. If I go one wedge top that has value a, which ranges between say 0 and 10, and I'm going to do 10 of these, and then I make another wedge top that has that itself is also doing 10 random values, and this one has a value called b that ranges between 0 and 10. If I look at the results, I don't get 10, I get 10 times 10. So if I look at this output, I've now got 100 work items, and if I look at these values and I step through them quickly, it makes more sense when I use the square bracket thing. So basically you can see that we go through the first value of a equaling 0, and then we go through A0, B is 0, A0, B is 1, A0, B is 2. So we get every possible combination of A's and B's. Then we go to A is 1, and then every possible combination of the B, and then every combination of the 2, 3, 3, 4, 4, 5, 4, 6. So it's a thing of you're making now 100 variations. So when you chain wedge tops together, you get more combinations, which is quite handy. So in this case, if I wanted even more variation, for example, I can maybe take out one of these values, maybe say the saturation, for example. So I'm just going to copy that to make sure I write it with the same name. Put down another wedge. Make this do, say, I don't know, 5 variations of color. And I make this be there. And there was between 0.2 and 0.7 as random samples. So now I'm going to get 10 times 5. So I get 50 variations. So now if I run this out again, and just to make it easier to step through the values, I'm going to call it more-rocks as the prefix. ROCKS dot PDG index, and let that do its thing. So now if I look in my Finder, I should be getting more rocks. Here we are. And I can step through these. And you can see these are going to start with, I guess the same amount of saturation variation for the first 5. And then the next one will have more saturation, and that'll be the same for the next 5, and the next one will have a different saturation. So very easy to make lots of randomized results very, very quickly. So the next one, if we jump to the slide, is sim wedging. So this is a very similar idea, but with a focus on sim. So if I go load up that example, accept, discard and open. Okay, so this is a very quick setup I did just to run, a very simple kind of explodey thing like that. Let me make that run in real time. So this is using one of the really handy pyroburst source presets. So this is a great HDA where you can dial in all these kind of like cool, crazy shapes, which are designed to work really well with pyro. So I put that there. I transform it to sit on it's a bit higher than the ground plane, and I run it directly to a popnet. So it's just using that as the source. So the source comes from the first input. I've set up a bit of pop drag, wind, and kill beyond if they fall below the ground plane or below 1, and it sims out. So it's all pretty straightforward. And then the question is, what happens relatively frequently when doing simulation work is you are handed a new setup, a new solver, a new whatever it is, and you go, I know that this, I've got to dial in the values, but you don't know what they should be yet. So, does it need, stronger gravity, more drag, more this, more that? You don't know. Tops can, again, help you there. So what we have here is, again, a bunch of wedges, where this time I've actually nicely named them. And with every wedge, I've separated out, in this case, 2 of them. So I've got one for the drag and one for the noise. So the noise, and so if I look at where these things are being driven, so this drag air resist is going onto the pop drag, and you can see that this is referencing at tops drag air resist. So this is a value between 0 and 2, and if I generate the node, you can see that I can preview the value and I can step through it. And these ones aren't randomized, so it makes it easier to follow later on, as you'll see shortly. This next one is the noise amplitude. So I'm guessing this will be on the pop wind. There it is, tops noise amplitude. It's between 0.5 and 5. And because these are separate values, so this is 5 randomized values for the drag. This will be 5, not randomized, sorry, sequenced values for the noise. So it's going to be 5 times 5. If I run this, we're going to generate 25 variations. The other thing that hopefully I pointed out last time is these dependency lines show you how these things link together. So this first value for drag links to these 5 values for the noise, and then these ones, and then these ones, and these ones. Similarly, if I click on any one of these, that will draw a line back to what it depends on. So it's a nice overview to show you how these things are linked. So with that all set up, this one, because there is no OpenGL top node, so occasionally you do have to fall back on fetches. So this one is pointing to, if I jump up in this network and jump up again and go over to ROPS, I have an OpenGL ROP, which is set to use the current camera and the OBJ path to here. So it's everything in here will be rendered. A handy trick here is that the OpenGL ROP lets you do text overlays. And so what I'm doing here is, you see, if I can make this a bit bigger, it's Command E, yep. I'm using this feature where you can put in quotes, in double quotes, text, and then you can put backticks and refer to tops attributes. And this will become a little text overlay on the top of the video. So this is going to render out, X amount of frames. So this is doing 10 frames for every input. And then what I do is I want to convert that into an MP4. So this uses a trick where FFmpeg, this is expecting to be given a batch of frames and say, process these. The way to do that is if I just let this cook, and I will let this run, and I will pause until it completes. Let me start it, and then you'll see what this is. It's already on disk. Excellent. If I partition by node, this is bundling up all these work items into a single essentially packed element, which is what the FFmpeg node expects. So if I run that, although it should recognize, it should recognize that it's already run. That's good for reasons. Let me find out why. Okay. So the error I was getting in the previous before was looked very system strangeness, complaining about missing libraries and stuff. I suspected I'm running a slightly older build of Houdini 20.5, and I've updated my OS X at some point. I just tried updating to the latest daily build of 20.5. It just works. So I think that's just FFmpeg being strange. Anyway, the point is, partition node takes all the results of these renders, bundles them into a single result. The partition node and the FFmpeg node know how to talk to each other, so that this basically provides to the FFmpeg node a text file that contains all the frames it wants to process. So when you run it, and of course this won't run it because it knows that those results exist, I can double click on the work item dots, I can click on the output here, and it will open up a finder, and I can look at the results. I can see that this is now compiled for me a full animated wedge, show me the results of what these things look like. So I can now sort of skip through and go, well, maybe these ones are a bit too wild, these ones are a bit too tame and controlled, maybe somewhere in the middle, like about, maybe that one, maybe that noise is a bit too much, maybe this one here. So drag, air resistance of 1, noise amplitude of 0.5 feels pretty good to me. So very handy way to get a scope on simulation values when you have a bit of compute resources available. So getting into stuff where I can't really show the demos in this recording, but I can talk about it a bit. Mass processing and check-in. Stuff that we did, and by we I mean my amazing good friend and super talented TD, Mr. Everything, Ben Skinner, set up back when I was at ALA, was we hooked tops into Shotgun, so that at some point we had lots of assets and we realized we're going to have to use them in a variety of formats, and to have LEDs for them would be quite useful. With Tops, he was able to hook into Tops' ability to talk to Shotgun. So I think, is it still Shotgun now? Yeah, so there's a few Shotgun nodes in here. So you could have it query the Shotgun database and make a work item dot for every model asset in the production. We could run that directly to a little SOP network that would run through things like 10 levels of detail, which is also driven through, I think, a wedge, so that it would write down it would write to disk a super decimated version of like 100 polygons right up through to the untouched version, and then another Shotgun node to then write those back into the database. This saved us oodles of time, and when we started to push into using those same assets for virtual production, for Unity, for mobile stuff, we didn't have to think about it. They were just all available there. And even in terms of the last rounds of rendering, some of the shots were getting a bit too heavy to render. We had LEDs on disk available so that we could tell RenderMan actually drop down to a LED of 3 rather than LED 10. And everything went through the palm, which is pretty handy. Well, it's not that. I want to go to the thing text. So again, I'm going to have to talk in a lot in sort of analogies here. I had another particular job where we had textures of things that had textures of skin, essentially, that had eyebrows baked into them, and it was deemed useful to, rather than have those be baked into the textures, to actually have physical grooms. I thought I'd have a go. What I did was I used Tops and the old compositing network to just do a lot of image processing. So I would take these very large images, so I would have it use a file pattern top to get to every texture we had on disk. So we would have color, normal pass, roughness, I think, the usual passes. And out of each texture, I would run whatever sort of contrast and keying and edge detect fields I could, just to get whatever useful information was available. With those inputs, I ran all of those textures into a very baroque looking SOP network that would generate curves in 3D space. I would use those to generate 2D volumes, which I could then project into 3D volumes, which I could then use as tools to style groom, so that I could then have like a very basic groom driven by the texture where I just had blurred out to say roughly where the eyebrow was. And then I could advect the curves through the sort of faked velocity volumes that I had extracted from the textures. Then I could also combine those with standard groom tools for adding bits of extra frizz and clumpiness. I could even then, again, using tops, as long as the total groom follicle count was the same, I could crossblend them. So I could mix and match them to get even more variation and write all these eyebrows out to disk. The results were not great if you were to compare them directly to the original textures, but it was good enough to get us unblocked. And I think it was a nice kind of use of tops and this ability to kind of take strange outputs from one location, transform the data, control it with sort of high-level numbers, and then push it out to another format in a way that without tops would have either been a lot of Python or a lot of sort of not quite easy to use stops networks, but tops made it really easy. So getting back to I guess bullet pointy takeaway notes, tops style. So I've shown you that you can have tops running right from the top level / stage location, and they can be using top fetches to refer to other ROPs in different parts of your network. I don't like that. I think that's a really bad way of doing it. So my way, which is the best way, is what I've shown here. So I more and more, if I know I'm going to be on a job that uses tops, I will start to move everything into a central primary tops network. So the first thing you see when you open up /obj will be topnet 1, dive in there, and everything will be downstream of there. So there'll be tops nodes to run the file pattern, tops to create attributes, all that stuff. But then in terms of the actual SOP networks, they will be inside ROP geometry contexts inside there, so that everything is all driven from one place. So that's what I just said. The synonyms, I think I mentioned already, but just to say again, it is slightly frustrating, such annoying that when you're inside tops here and you want to put down a dedicated COPS container to do compositing work, like I was putting it before, your first reaction is to go tab and then COPS, and you get a COP network like this kind of thing, but that's not a top COP network. What side effects have done for their own reasons, I'm not sure why, is they don't use the shortened op name for these things. They use the full name. So don't put down a COP net, put down a compositing output. So there's a ROP composite output. So that's the one that you could wire in. You don't put it down a SOP net. Of course, you don't. You put down a geometry output. So there's a composite output, geometry output, a Solaris output? No, not even that. It's probably a USD output. Probably USD output. Yeah, that's the one. So as long as it has inputs and outputs, then you know that it's a tops context one. That drove me insane when I couldn't find the nodes I need. Now you know. This is how they're called. I think they are all grouped now under a category called... no, they're under separate categories themselves. So there's no top level folder here for all these types. So you just have to know that it's not COPS, it's composite. It's not SOPs, it's a geometry, and it's not LOPs, it's a USD output. So that's that. As I mentioned before, sometimes you have to use fetches, but wherever you can, if there is a built-in tops node to do what you want, better to use that. This is controversial. I had a few people call me out on it in the masterclass. They're probably right. I don't like the HDA processor. So for context, you can put down an HDA processor. And what this does is you can point it directly to your HDA node on disk, and whatever the input is coming through, you can have this auto wake up all of the parameters that drive the HDA by pressing this update HA parameters button, and then you can control it through tops. My misgiving with this is twofold. The primary one is that I don't make many HDAs. I think it comes down to a mild imposter syndrome where I don't think anything I make is good enough or worthy enough to be bundled into its own node. That's just me. The other more abstract reason for that, or for me not liking it, is that when it errors, it's not clear why, because it generally just says, here is an error. The HDA complained about this particular thing. I'm used to now with this kind of stuff to dive into a context, find the node which is erroring, go, oh yes, Matt, you idiot, and fix it. With HDAs, you kind of have to have it in two places. So you have to have the unlocked HDA somewhere else, and you're expanding it and looking at it and trying to interpret why this error here is causing errors over here. It's just a little bit opaque for my liking. But as I said, I'm an idiot who doesn't use HDAs enough. Others seem to swear by them and say it's awesome. They're probably the experts and not me. But I'm a simple guy with simple needs. I like simple tops. And the last one, tops is a workflow sketcher. This one I quite like to kind of call out, just in terms of when you're first kind of joining a show, or you get given a task or whatever it is, it can be quite daunting at first to have a sense of what it is that you need to do. What is quite nice about tops is that you can almost use it like a flowchart to help you design your thing. So you go, well, actually, the first thing we're going to have is you're going to have lots of files on disk. So that'll be a file pattern top, and then I'm going to have to create attributes to pull out the names of the things. But then I'm going to have to pull files from some other location. That'll be there, and then I'm going to merge those based upon some hierarchy, or maybe I'm not going to merge them, or I'm not going to do some clever thing, I'm just going to merge them directly, or maybe I've got to partition them together based upon some attribute. So I'm going to use a partition by attribute. So you can kind of like generate up your flow of what the thing is going to be, because then that's where you might then maybe do some sort of geometry processing, and then that might go out to USD. So you can almost like sketch out your pipeline here in a way that that actually becomes sort of like functioning code, which is quite cool. So, almost any other sort of like sketching tool, you're using, Miro to sketch it out, or you're using just, Google, flowchart docs. At some point, it doesn't become an actual representation of the work. This is a representation of the work. This is actually what you're doing. And the more I get into sort of like complicated workflows, the more I tend to actually go into tops first, just to help me sort of get the idea roughly out of my head in a vague cloud into an actual sort of workable, flow of pipeline nodes. I got like that. What else? Top tricks. Partitions, expand, and collapse. Yes. So I mentioned before that partitions. So in the very loose analogy of work items as points that can be packed, a partition is that. So you can see that we've got all these work items here, and they've been packed into a single sort of vertical bar. They can be unpacked again. So if I go let's expand, partition expand. So I put this down and then run it. You can see that I get back the nodes that I had before. This can be quite useful. So in the way that, again, it's in my mind, it's almost a direct analogy that sometimes you're running to RBD and you have to pack stuff to make it really elegant and just to flow it down through many, many nodes. But then at some point you have to unpack it again to do work. Similar thing here. Sometimes you want to partition up just to keep things all sort of nice and collapsed together, but then you can expand at any given time. That's quite handy. Merging top strings by attributes. Oh, I just mentioned that. So let's see if I can make a working example of this. I'm going to pause, give myself some thinking time. Right, here's an example. So this file pattern, it's the same as before. I'm getting all the images in HFS Houdini Pick. This one is getting all the MP4s in my movies folder. And then with each of them, I'm running a filter by range. So I'm just keeping the first 11 of each. And then I'm running a partition by index. And so what this does is it tries to make up pairs of things, and you get to control how the attributes on the work items get merged. So is it will it take values for the first or the last? All these things, whether they be summed together. There's a whole bunch of different combinations. Append to array is quite useful. So if I look at these guys and look at, say, the first one here, you can see that I've now got two values. So these have all been copied into arrays, and I've got the file name from the first and the file name from the second. Examples of that I've used in the past is, I've got images from one location, say like diffuse textures, and I've got normal maps from another location, and they should be paired together. So you want to make a little set of the PBR textures that belong together, but they're in different folders. You can keep them collated and bound together. So this is just matching by index, but in that case, I'd be matching by name. So I would extract out some property of the name, say, the asset name, and then say partition based on that. That can be quite useful. Other things I've done is, it's basically that. So, pairing up, images and text files, pairing up, geometry and materials. You can be very organized. Like a lot of the sort of, what feels like busy work, but it's actually quite fun busy work in TOPS is a lot of this sort of initial setup stuff where you have lots of things coming from lots of different locations on disk, and you need to conform them somehow so that it's very clean by the time you feed it down into your SOP network or your simulation or whatever you need. The other way that's quite useful is it can help you weed out invalid values. So I think in one of the early examples in this recording, there was an image file that Houdini couldn't load. Well, I can find it and filter it, make sure that it never hits the ground. Similarly, if I'm looking for image sets that have to have the complete set of, diffuse, roughness, metalness, I can weed out ones that don't have a full set and they can just be ignored, and I can send an email, I can flag it, run them to a separate output folder, lots of things like that. That's, you could do it in Python, you could use ChatGPT, but it's quite nice to be able to do that all inside TOPS. Going back to my list, labs. This is another interesting one where I know labs doesn't, a lot of places won't let you install labs. I think it's really useful. A lot of the labs nodes that are in here are great. So if you type in labs, you get these. It's a fairly small set, but they're really useful. One of the most useful ones I've found, which again, I might have shown before, sorry, this recording split over a few days, is the labs filter by value. I can never remember how to use the filter by expression, because this relies on you knowing HScript ways of doing it, which I can never remember, or you can use Python, which again I can never remember. This just gives a very clean way. I think this should be promoted to a standard TOPS node, has some side effects if you agree with me, where you just type in the attribute name and what kind of comparison to do. It's really, really clean and simple. And there's lots of other little labs nodes like that are worth investigating. Just save loads of time. The keyboard shortcuts, I've discussed that. That's the square brackets is by far the most useful one. Shift V to cook. They're the ones I use 99% of the time. The line draw one, that's an interesting one. Let's see if I can force this a bit. So I'm going to copy that to there, and I'm going to do a partition by combination. So this is the one where it can make, so partition by combination combines every node with every other node to make a new node. So if I do this kind of thing, I should get a ridiculous amount of nodes. You can see this is cooking for too long. Yeah, so from 116 inputs to 1, 3, 4, 5, 6 to 203, it's made 9,000 possible combinations, which is a lot. And you find that as this gets really complicated, if I were to put like another a partition by node like this, and then cook that one. If I click this, you see everything starting to light up, and this overview gets slower and slower. So I've been in situations where I had very complicated TOPS graphs, and keeping track of all of these combinations, TOPS itself is getting very, very slow. You can fix that by saying don't show the entire upstream graph. So if I hit D for display options and go to, where is it, next down the bottom, task graph, and the number of max dependency depth. So if I go to say like just 1 and enter and close this, now hopefully it just does that node by itself, which is quite fast. Sometimes you want to see a bit more. So if you go to a depth of 2, this should show just this one and the nearest one. Yeah, so that just does that. So it's much, much faster. That's probably the hottest of the hot tips that I can think of. I think that was it. So onto resources. So almost everything that I've talked about here in one flavor or another is on the wiki. So if you go to CQ Wiki and go to the tops page, so Houdini and then tops, you'll notice a lot of these visual examples look very familiar because they're the ones that I just spoke about. Oh, look, it's a rock generator, and the other things about this stuff as well. So nearly all these examples are here. I'm going to check the recording. If there's stuff that I have not put on the wiki, I'll put them on very soon. Other really useful resources. Tom and Taylor are very helpful. If you see them at a conference or see them kind of answering your questions in forums and things, say hi from me. They're both wonderful. To get to them, generally speaking, it's through support tickets. So if you have a question about tops, 99% of the time, it's one of those guys will be sort of providing answers through to the support team. They're great. I did not collect the questions from the floor. I think the ones that I can remember, one was someone calling me out on the HDA thing, which I think I explained. And the other one was, I don't remember, but I think I do remember going back through the examples and saying, oh, this is what you're talking about. It's this example here. So I think it was already covered. So what's my takeaway of all this? Tops is both easier and harder than you think. And I think that's even not the right way to talk about it. I think Tops is deceptively simple. You can see that ultimately it's just high-end string replacement, really. You're making variables that have strings and values attached to them. You can use those to drive the rest of Houdini, but that gives you a huge amount of power. And it's, for me, the moment of kind of getting SOPs and going, oh, I can do so much with this. Tops was a similar thing. I kind of railed against it for a long time, and then suddenly I realized, oh, this is actually very, very powerful. And I think it's kind of got me to where I am today, which is the work I do. If you really want to sort of scale up your work, generate big data sets, Tops is a great way forward. So, hope you found this useful.